Hello everyone. Hello my dear professor and my dear classmates. My name is Musab Abdurrahman and today I'll be talking about the optical properties of semiconductors and photoconductivity. From the heading itself, we can understand that these properties are being studied using the photons because optical things are related to light, which is photons. Then the contents of our presentation will be optical properties of semiconductors. Semiconductor background, as you know, the semiconductors are materials that have properties intermediate between the conductors and insulators. And the optical properties of the semiconductors plays an important role in the electronic devices, such as solar cells, light-emitting diodes, lasers, and others. Then we'll talk about the basics of absorption, reflection, diffraction, and transmission, and photoluminescence. The second part of our presentation will be about the photoconductivity. We'll explain the basics of photoconductivity and how that photoconductivity occurs. The conductors can absorb light energy at specific wavelengths, which depend on their band gap energy. You know, the band gap is the minimum required energy for the electron to move from the valence band to the conductive band. And the absorption occurs when the incident photon has energy which is greater than the band gap energy or equal to it. As you can see here, we have interband and interband absorption. I'm going to talk about the differences between them, starting with interband. Inter means between, and this happens when the electron in the valence band absorbs the energy from the photon and moves to the conduction band. So it moved from band to another band. It happens between two different bands and two different electron levels. So it's called inter, between. On the other hand, we have intraband. Intra means within. As you can see in the bottom right, the electron absorbs the energy from the photon, and the energy is less than the band gap energy, so it's only moving in the same band, within the same band. Also, this can happen in the conduction band. As you can see in the conductive band here, the electron absorbed energy and it's moving within the same band. And as you can see here on the right side, the electron absorbed energy from the photon, and this energy is greater than the energy gap, so it moved from the valence band to the conduction band. The transition from valence band to the conduction band. That's why it's called interband transition. After the transition takes action, we will have an electron in the conduction band free to move, and the hole was created in the valence band. The photon energy, HV, must be greater or equal to the energy gap, and the frequency, if you want to find the frequency, we divided both sides by the constant h, then we will get V greater or equal to Eg over h. And here, when the frequency is equal to energy gap over h, we call it absorption h. And it's when the absorption just starts. And for other properties, reflection. Semiconductors can reflect light at their surface similar to other materials. And transmission. The light can be transmitted through the bulk of semiconductors when the energy of the photon is less than the band gap, so the light only will be transmitted. Another property of semiconductor, which is photoluminescence. When a semiconductor absorbs photon with energy greater than the band gap energy, it can re-emit light through a process called photoluminescence. And the second part of the presentation is the photoconductivity. So how does the photoconductivity occurs? It occurs when light is absorbed by a material such as semiconductor. The number of electron hole pairs increases, resulting in the increase in the number of charge carrier and raises in the electrical conductivity. The increase in the electrical conductivity is due to the excitation of electrons across energy gap. Numbers of free carriers increases, so the conductivity will be increased. Finally, I would like to thank you for your time, and if you have questions, we can discuss them in the next class. Have a good day.